This video is for class 9 physics, and in this video we are doing experiment number 4 from our practicals. This is our third experiment. The object of this experiment is to measure the volume of a metal bulb, okay, by the method of displacement of water first, and then again by measuring the radius of the bulb using the Vernier calipers, and thus using the formula of the volume of a sphere. Hence we need to compare the accuracies of these two methods. Now the apparatus required will be a metal bulb sphere, okay. The one which is used in the simple pendulum can be taken, which we have taken, right. Water, we need a measuring cylinder, a thin string, a thread, and Vernier calipers. Now going to the theory portion. In this experiment we measure the volume of a metal bulb in two ways. Number one, by the method of displacement of water using measuring cylinder, since a metal bulb when immersed in water displaces equal volume of water, right. And number B, by measuring the radius r of the bulb using the Vernier calipers, then by calculating its volume by the formula V equals to 4 by 3 pi r cube. Okay, so let us go to the experiment part. So coming to the observation part, although I have already filled the table first, right, I'll show you how the experiment is done also. Now here I have come to the table for this line. Value of one small division of a measuring cylinder equals to 0.5 centimeter cube. How does this 0.5 comes? I am explaining right now. As you can see, between 5 and 10, okay, let me zoom the image first, okay. I hope you can see now. Between 5 and 10, right, it is 5 milliliter or it is 5 centimeter cube. Now this 5 milliliter or 5 centimeter cube has been divided into 10 equal parts, that is 1 2 3 4 5 6 7 8 9 10. So value of one small division here, this volume, right, one small division here, this volume, we are talking about this volume. So this volume will be 5 centimeter cube divided by 10, hence we shall get 0.5 centimeter cube. So that is the minimum volume this measuring cylinder can measure, right. I hope you understood the value of the one smallest division here. Thus I have written value of one small division of the measuring cylinder equals to 0.5 centimeter cube. I hope you have understood till. Coming to this table here, right, it has total 4 columns. The first column is about number of observations. Total we have done 3 observations. Then second column is about initial level of water, right, before the bulb is immersed in the water. And the third column is about the final level of water, that is V2, when the bulb is immersed in the water. And thus by subtracting this V1 from V2, we shall get the volume of the bulb, which is actually the volume of the water displaced. So that is all about number 4 column. So let us go to the experiment part. As you all know, we have a concave meniscus for water. If you remember, we have a concave meniscus for water, and we are supposed to take the lower level. Here you can see this the water is at this level. This is just the reflection of the other side. So water is at this level here, right. Now the value of this level will be this longer line is 35 centimeter cube, this is 35.5, and thus this is 36 centimeter cube. So here V1 is 36 centimeter cube. Thus V1 is 36 centimeter cube. This is the initial level of water. Let us find out the final level of water after we immerse the metal bob. Thus, after immersing the metal bob, as you can see here, the final level of the water is this line here, and it is 40 centimeter cube, and it is 40 centimeter cube, right? So V2 is 40 centimeter cube. So let us put this data in the observation table. So coming to the observation table part, here you can see the initial level of water was 36 centimeter cube, the final level of water was 40 centimeter cube. Thus by subtracting this, right, we are getting 4 centimeter cube as our first observation. Now similarly the other observations were also done, keeping the initial levels different, and we have calculated the volume of the bob, and each time it is coming 4. Now to find the mean volume, I am supposed to add this 3/4 and divide it by 3, because there were 3 observations. Thus I am getting 12 upon 3, which shall give me 4 centimeter cube. Now coming to the second observation table, where we are supposed to use vernier calipers, right, in order to find the radius of the bob. Now to use vernier calipers, as we have already done in experiment number 1, first we are supposed to find the least count of the vernier calipers, then only we will proceed to measure the radius of the bob. So let us try to find the least count of the vernier calipers. Now to calculate the least count of the vernier calipers, I am supposed to know the number of divisions in the vernier scale. So the number of divisions on the vernier scale will be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So there are 10 divisions on the vernier scale, and the value of one smallest main scale division is 1 millimeter, right, which is coming up to 0.1 centimeter. Thus the least count can be taken out by dividing the value of one smallest main scale division, which is 0.1 centimeter, upon the number of vernier scale divisions, which is 10. Thus I shall get 0.01 centimeter as my least count. So let us fill these values in our observation table. So here what you have done is we have just filled the data which I just observed. So number of divisions on the vernier scale, it was supposed to be 10. The value of one main scale division, which is 0.1 centimeter. Thus the least count will be x upon n, like we have done in experiment number 1, and I shall get 0.01 centimeter. So this is the least count of the vernier calipers which we are using. Now coming to the table, here also we are having 3 observations, right, and we need to know the main scale, as you all know, then the vernier division which is coinciding, right, with the main scale, and we need to find the vernier scale reading by multiplying the coinciding division with the least count, and thus getting a value which is vernier scale reading, and finally adding the main scale reading with the vernier scale reading, I shall get total reading. Now to measure the radius of this particular metal bob here, right, it has to be placed in between the outside jaws, as you can see in the figure, and then take the reading of the main scale and the vernier scale. So let us zoom in and and try to find its reading, right? So while zooming in, here you can see the main scale reading. Our motive is to find the main scale reading first. I have to check the 0 of the vernier, right? And you can see this 0 has not reached 2 yet, and so the reading will be this particular reading here, which is our main scale reading. So the main scale reading is equal to 1.9 centimeter, right? And let us check out which vernier division is aligned, right? If you can see properly, this particular one, the 9th one, is aligned with the main scale, right, properly. So as you can see, this one is also aligned, but I'm preferring the first one, okay, the 9th one right here, right, which is aligned. So the vernier division which is aligned, like the vernier division is equal to 9. So putting these values in the table, right, putting these values in the table and then calculating, let's see how much do we get the radius of this particular metal bob. So coming to the table part and filling our datas, here you can see we got the main scale reading. The main scale reading was 1.9, right? Our vernier division which was coinciding was 9, thus getting the vernier scale reading by multiplying the coinciding division by the least count. So coinciding division was 9, least count is 0.01, thus I shall get 0.09. now to find the total reading, I am supposed to add this main scale reading which is 1.9 and the vernier scale reading which is 0.09, thus I am getting 1.99 as my total reading. I have done this second observation and third observation also, thus getting the values of main scale which should not change, and I got the vernier divisions also and thus the total readings as well. So to find the mean diameter we have done some calculation. Let us go to the calculation part. So coming to the calculation part, this you should do on the blank side with pencil, right? So for the mean diameter I have taken these 3 readings and then added them and divided them by 3 because the number of observation were 3. So after adding them I am getting 5.98 upon 3, thus I am getting 1.993 as my mean diameter. So let us go to the table again. So here you can see I have written the mean diameter as 1.993 centimeter, right? The centimeter just moved out. Okay, let's see, it is 1.993 centimeter. And then to find the radius of the bob, right, r equals to diameter upon 2. So this diameter was 1.993 upon 2 shall give me 0.9965 centimeter. Now using this radius I am supposed to find the volume of the metal bob. So the volume of the metal bob, right, so the volume of the metal bob will be calculated by using the formula V equals to 4 by 3 pi r cube. So thus by using the formula I have calculated the volume to be 4.1429 centimeter cube. Let us go to the calculation part. Okay, I am taking the pi as 3.14. So coming to the calculation part, here you can see the volume has a formula V equals to 4 by 3 pi r cube. This is the volume of a sphere, right? So putting the required values, pi as 3.14 and r as 0.9965, whole cube, right? So I have calculated and I have got my answer to be v equals to 4.1428, but in the book I have written 9 because there were many numbers after this also, so I am rounding off, so I am getting 9. I am writing 9 on the book, right? So let us go back to our book. Thus now writing the volume of till 3 significant figures, I am writing it to be 4.14 centimeter cube. Now it is clear that using this method, the Wernicke caliper method, is much more accurate than the displacement method. Thus the final result will be the volume of the bulb measured by the method of displacement of water was found to be 4 centimeter cube, whereas the volume of the bulb measured by using the Wernicke calipers is 4.14 centimeter cube. I hope you have understood the experiment. This much for this video. Thank you so much.